All right, quickly we're going to motion under gravity. Motion under gravity. When we are done with motion under gravity, then we'll now move to, I think our next class will now take projectile motion. Projectile motion, and then we'll also look at simple harmonic motion. All right, motion under gravity. Just talking of the motion of a body, all right, under the influence of gravity, under the influence of gravity, under the influence of gravitational force. All right, now let's quickly go and look at the introduction. Now it says, consider two objects of different sizes dropped from the same height above the earth's surface. Ignoring air resistance, which of them will reach the ground first? I'm sure we are not new to this phenomenon or to this exercise or experiment. So definitely, since air resistance is not considered, it means that both bodies will drop at the same time. At the same time. Now, observation: the bodies reach the ground at the same time. Now, both bodies reach the ground at the same time in absence of air resistance because they are moving with the same acceleration, and that acceleration is called acceleration due to gravity. If the motion is a linear motion, then we have our normal a value for acceleration a. We have our normal acceleration. But when the body, when it is dealing with a rising, when the motion is the motion of a rising and falling body, then we'll consider the acceleration to be g, which is acceleration due to gravity. So we say acceleration due to gravity is defined as the force per unit mass on a body under the influence of gravity. The force per unit mass on a body under the influence of gravity, or we say is the force of attraction or the gravitational force of the earth on a unit mass. So we have G equals to F over M, because from F equal to mg, we have G to be equal to F over M. Now, let's see additional information we have concerning acceleration due to gravity. So number one, G is constant for all masses. On Earth, G is constant for all masses. And also it is a force. It is a force intensity, gravitational pull, a force intensity. It is also a vector quantity. It has both magnitude and direction. Either it's acting upward or the body is coming down. Alright, then the SI unit of acceleration due to gravity is the same SI unit as a linear acceleration, which is meter per second squared. Now, the difference between the equations of motion, of linear motion, and the equations of gravity, they are the same thing, just that in equations dealing with gravity we use only three equations of motion. Three equations of motion. The equation of motion, which is S equal to V plus U over 2 times T, is not considered when we're dealing with the motions under gravity. Why? Because acceleration is always involved, G is always involved, but G is absent in that formula. That is the reason why we are not considering it at all. So we have the first one, which we got from V equal to U plus or minus 8. You know, having plus or minus because the body can be dropping or it can be projected upward. So if it's going upward, the value for G becomes negative because the body is acting against gravity. And when it's coming down, the value for G is positive. Alright, so that's why we're having plus or minus. So you have V equals to plus or minus, U plus or minus GT. So when we have A, we have replaced it with G because we are dealing with rising and falling bodies. Then the second one becomes, instead of S, we now have H. Instead of linear distance, we now have vertical distance called the height. So S equal to UT plus half AT square becomes H equal to UT plus or minus half GT square. And the third one, V square equal to U square plus 2AS becomes V square equal to U square plus or minus 2GH. 2GH. So these are the basic equations of motion under gravity. Now let's take note of some important key points we have here. So we said when an object falls from a height, when an object falls from a height, its initial velocity u is 0. Take note. When an object falls from a height, its initial velocity is 0. Number 2, when an object is thrown or projected vertically upwards and gets to its highest height before coming down. At that highest point the body gets to before coming down, that highest point, the value of v, the final velocity, is equal to 0. Third, when an object is coming down or descending, when an object is coming down or descending, g will be positive. I said that earlier. And when the body is going up or ascending, the value of g becomes negative. So g can be 10 meters per second square, or you can be asked to use 9.8 meters per second square. The last one, the velocity of throw of a body is equal to the velocity of catch. What does that mean? The velocity of throw of a body is equal to the velocity of the catch. Therefore, the time taken to get to the maximum height is the same as the time taken to come back to the level of throwing. The time it takes to go up is the same as the time it takes to come down. So let's quickly look at 2 examples and then we'll move on. Example 1. A mango fruit drops from the top of a tree 45 meters tall. So that means the height of the tree is 45 meters. How long does it take to reach the ground? Take g to be 10 meters per second square. 10 meters per second square. So the same approach we use for equations of linearly accelerated motion is the same approach we are going to use here. Now let's list out the parameters we have. Now the body drops. It drops. Alright? From the top of a tree 45 meters high. That means h. Our h is 45 meters. That's one. How long? Time. We are asked to look for the time it takes the fruit to drop to the ground. So we have t. Then g is equal to 10 meters per second square. There's one more parameter we need, and that is u equal to 0. From the notifications I gave us earlier on, I said when the body drops, the value of u, initial velocity, becomes 0. So definitely we have 4 complete parameters. We have u equal to 0. We have g equals to 10, positive 10 because the fruit is dropping. We have h equal to 45 meters, and we are looking for t. So you have u, you have h, you have t, and then you have u, h, t, you have g. So which of the equations are we going to use? That becomes h equal to ut plus half gt squared. When you substitute in the parameters, the value for the parameters you have, we are going to have 3 seconds. The same thing applicable to the next question. The same thing applicable to the next question. You check out the 4 things you are given. But let's see, there's a bit difference in this second question. A stone of mass 0.75 kilogram is projected vertically upwards with a speed of 5 meters per second. Calculate the maximum height reached. The same thing. Calculate the maximum height reached. So we have no business with the mass. We have no business with the mass of the body. All we need to do, list out our 4 parameters, and then we apply the right equation of gravity to solve the question. Now, we have that answer to be 30 meters per second for the other example. Alright, then we see, let's quickly look at, okay, this is an experiment to determine the value of acceleration due to gravity and all that. Alright, now we'll see that from the experiment there's a formula derived, and the formula is g equal to 4 pi square over the slope of the graph. Here the formula is in equation 2. You have t square over l equal to 4 pi square over g. If you have the l, the length of the pendulum of the experiment, and t square, I think that's the period of the experiment, then 4 pi, your pi is 22/7. If you substitute those values into that equation, you're going to get a decimated value for acceleration due to gravity. Now I'm going somewhere. Look at this 7.4. So reasons for the variation of g at different locations on the earth. Why do we have mass is constant? And that's one of the difference between mass and weight. Take note. Mass is constant. Weight varies. Weight varies. The mass of a body is constant because the mass of a body is the quantity of matter the body contains. Weight varies. So while do we have variations of g at different locations on the earth. The acceleration of free fall due to gravity varies from place to place on the earth's surface because of the following reasons. Number one, the distance of objects on the earth's surface to the center of the earth is not the same. Number two, the shape of the earth is not a perfect sphere but is elliptical in the sense that the radius of the earth is not uniform on the earth's surface. Number three, the rotation of the earth about its polar axis is not perfect or uniform. In other words, the earth wobbles. Something like it rolls, like it wobbles. It is not perfect. Number four, the magnitude of the force of attraction of a body to the center of the earth varies. My attraction to the center of the earth varies from the attraction of another person to the center of the earth. And number five, the variation in the earth's density. These are reasons why G varies at different locations on the earth. Alright, as we bring the class to a close, you see the difference between mass and weight. I've told us that before. Mass is the quantity of matter in the body, the quantity of matter a body contains. Weight is the force on a body with which it is attracted towards the center of the earth. Number two, mass is a scalar quantity. Weight is a vector quantity. Number three, mass can be measured by a chemical balance or a lever balance, while weight can be measured with a spring balance. Number four, the SI unit of mass is kilogram. The SI unit of weight is Newton. F equal to mg. W equal to mg Newton. Number five, mass is always constant. Number six, weight varies. Then we can see relationship between time and distance covered by a body falling freely from rest. Still from the same equations of gravity we have been using, these equations have been derived. And we also see the graph of a body thrown vertically upward and made to come down to the projection plane. Alright, so these are cases with their respective formula. So one key thing to understand is this. Once the question is given, understand that the question will always come with four parameters, three given parameters, and then you'll be asked to look for the fourth one, just as we solved some questions using equations of a uniformly accelerated linear motion. So the same thing is applicable to motion under gravity.